Alright guys, got another one today on algos made simple. This one is ranked medium on Leetcode, but I think once you see how simple we solve this one, you'll realize it's pretty easy and something that you would love to encounter in an interview or just wherever you might run into a problem like this. So with that being said, let's dive right into it and see if we can get this simple solution and get things rolling. This is Leetcode152 MaxProductSubArray. It states, given an integer array nums, find a contiguous non-empty subarray within the array that has the largest product and return the product. The test cases are generated so that the answer will fit in a 32-bit integer. A subarray is a contiguous subsequence of the array. So I would let the interviewer know, I understand I'm getting an array of numbers, and my goal is to find what sequence will return the max product. So I want to return the max product of it. And that could be the entire array. It could be all the numbers multiplied together depending on how it sets up. It could be the numbers 1, 2, 3, the first three numbers of it. It could be just one number in it. What it can't be is, because it's got to be a contiguous subsequence, I can't take the first number and multiply it by the fifth number and skip all the numbers in between and say, okay, that's the answer I want right there. That's not how that works. And I could also, if you wanted to go a little bit further, just to kind of talk through it with the interviewer, if they're all positive numbers, so excluding zeros and negatives, then I understand that the entire array, just the product of the entire array, is going to be my answer. If I have an array full of negative numbers and it's an equal amount of numbers, then I know that the entire array again is going to be my answer, the product of it. If I have an array with a 0 in it, I probably don't want to utilize that 0 unless it's surrounded by all negative numbers. Then in that case, 0 would be my maximum. So you can kind of throw some stuff out there just to show that you're thinking through it, whatever you want to do. But with that being said, let's dive into the examples. You've got nums equals 2, 3, negative 2, and 4, and your output is, of course, 6. So with this being the case, you'd have 2 times 3 is 6. 6 times negative 2 is 12. Negative 12 times 4 is negative 48. So what'll be different on this one compared to like contiguous sum of a subarray is you would think, okay, I've got my 6 here, I'm running this negative 2, that gets me to negative 12, I'd rather just keep the negative 2 and ditch the negative 12 when I'm going through the list. You can't do that. You want to keep your minimum as well as your maximum, because what if you encounter a negative 1 here at the end? Then you're going 6, negative 12, negative 48, but then you're going positive 48. And you would have missed it if you switched and gone to this negative 2 and ditched the negative 12 possibility. So that lets us know we're going to have to keep up with our current max and current minimum because it's multiplication. So two negatives together could end up being our best positive number, our max product. So that's something to keep in mind as we go here towards writing our game plan. But this next one, and we kind of already spoke about this, this is negative numbers surrounding a 0. So you know negative 2 times 0 is going to be 0, negative 1 times 0 is 0. 0 is the highest between negative 2 and negative 1. 0 is what we want to spit out there. And again, that is just confirmation that you can't say, okay, well, what about negative 2 times negative 1? You can't do that. They're separated. They're not contiguous. So with that being said, we get our game plan going. And our game plan, as we talked about, we're going to need to keep track of the current max and the current min. So we can utilize that because the current min, again, can end up saving the day and being the hero of it. We also need to have a max product where we're updating that with whatever the new maximum is, because you could have 6 here and then you could never end up positive again. So you want to return that 6. So with that being said, what else do we need? We need to have a max function, and the max function needs to look at the number that we're looking at, because just the number itself by itself could be our answer, but it also needs to look at that number times the current max and the number times the current min, and that's going to find it. That'll be able to find our max at that current point in time. But again, we talked about needing a current min. Our current min will be the minimum of those same things. So you can just kind of copy paste here. Again, that's going to be the minimum of those same things. And the only other thing we need to do, let's see, of course the max product will be the max between the current max and the previous max product. And you know, if you want to get real technical with it, we're going to utilize a for loop at some point in this. So you've got a little game plan together. That's enough for us to be able to dive right into this one and start going. So we've got max product sub-array, and we're getting nums passed through it. All right, so we've got our current max, current min. We know we need to set them to something. They're going to be multiplied times the number. So we can't set them to 0, so setting them to 1 makes sense, so it will not affect anything we're passing in through it. And again, that's not going to mess us up. Even if we have all negative numbers, this current max and current min are never going to get looked at in a way that that positive 1 can end up being the result and the return, because all they're being utilized for is to get multiplied by that number. So we're good there. We want to go ahead and initiate this max product and set it equal to something. There's no reason to go ahead and say, well, max of the array or whatever like that, because you're going to pass through every number anyway. So with that being said, let's just do nums at index 0, because we know we're going to have at least one number in it. And then it's time to utilize our for loop. So we'll just go for num in nums, and we'll say current max equals, and we can go ahead and come up here and copy this. Current max equals the max of the number times the current max, what the current max was, and the num times the current min, what the current min was. And then our current min is going to be the same thing, except, as we talked about above, the minimum of these numbers. Here's a problem we're going to run into, though, real quick. This current max is getting updated right here, so it's not going to be the max that we want to utilize here. So what we'll do is we'll just simply come here and we'll make a copy, previous current max. Yeah, that was fine. Previous current max equals current max. And you don't have to use it here, but just to make it more cohesive and more understandable, we'll do the previous current max right here, and then we'll utilize previous current max right here. So that uses that previous current max to utilize in these findings. So we got our new current max, our new current minimum. What's left to do on this iteration through the loop is to say max product. And for here, we're taking the maximum of the current max and the previous max product. There's no reason to look at the current min because that's our minimum at this point in time. So it's not going to be as high as the maximum, even though you're dealing with negatives and stuff like that. If your negative comes into play, that it's going to turn positive. It's already happened right here and already been set to the current max. So there's no reason to use the current min here to look at. So once you get through all of that, all you'll simply do is return the max product. So that's how simple this one is, guys. You just have to keep in mind that you need to remember you're going to have to utilize the absolute value in certain situations, because you're going to need, if there's a negative here, a negative number that comes through and there's a negative for your current min, that could end up being your highest positive, and that could be what you want to utilize. So you got to keep that in mind because it's multiplication. So going through this, you can look at this 2, 3, negative 2, and 4. We'd come down here. You'd have the 2 getting looked at in the max. So let's go over here in the corner here and say current max, current min, and run out of room for where I want to be. Let me see if I can move that up a second. And, well, okay. So that's not working the way I want it to work, but we'll go over here and just say max product. Alright, so we're going through, and don't confuse that as part of the code. The code ends here with the return statement, obviously. So we'll go here, and we'll come down. You got the 2. The 2 initially is going to be our current max and our current min, and it's going against the 2 itself, which was already set to be our max product. So that's all cool. We made it through the first number. The second number is that 3. That 3 is going to come down here, and it's going to be the max of the 3. The 3 times the current max, previous current max, which is 6, or times the minimum, which is 6. Whatever, the current max is going to be updated to 6. Our current min is going to be the minimum between 3 6, and 6. So obviously that's going to make our current min 3. And then we'll come here and say our max product is between 6 and 2. It's going to be 6. We'll go to the next number, which is the negative 2. We'll come here and say the max of negative 2, negative 12, or negative 6. Is that right? No, yeah, negative 6. So in this instance, our max would be, for the current max, again, it's between a negative 12 and a negative 6, and the number, our current max would be that negative 2. So current max goes to negative 2, and our current min, on the other hand, would be that num, that negative 2 times the previous current max, which is negative 12. Our current min would go to negative 12. Our max product would stay at 6. So then we're going to come here and have that 4. That 4 will come in here and be max of 4, or 4 times the current max was negative 8, or negative 48. Obviously our current max would be 4. Coming down here, same scenario, but it's going to be negative 48. Is 4 greater than our 6? Nope, 6 stays the same. If we had, again, that negative 1 come through, the negative 1 will get looked at, and it will, over here, so we have negative 1 times 4, negative 4, and of course 48. So our current max would go to 48. Our min, which is not really as relevant here, but anyway, you'd have negative 1. You have negative 1 times the current max, which the previous current max was 4. So you'd have negative 4 there, or again 48. So the current min would go to negative 4. Is 48 greater than the max product 6? Yep. So 48 would be your new max product, and that would just happen through as many numbers as you had. But anyway, the code works. We've tested it, and it runs in O of n. This one, again, is very simple, guys. Just have to keep in mind that you need to work with the min and the max. If you remember that for this multiplication, that you have to work with the min and the max, because your min could end up being your hero, you've got this one. You've got it solved. That's all you remember. So anyway, thanks for watching, guys. If it helped you out, please like and subscribe. If you think you know an easier, simpler way to do this problem that's easier to recall, please comment it. That way we can all utilize it. Or if you see anything that you think is incorrect or have any questions on, please comment below. Thanks again, guys.